All right, welcome back. We are Game 3001 in the winter 2021 semester at George Brown, and it's week 6, part 2 of our broadcast. And today, where the first part we talked about some A-star pathfinding heuristics, and we're going to go into details on how to implement those things as we go. And let's talk about what the plan is for this lab. So this is all the stuff we're going to try and do. We're going to create something called the navigation object class, which is going to help us, kind of do some algorithm improvement compared to what we had created last week when, you and I were both bothered with some of the code that was out there. I was like, oh, we got to improve this. It needs to be changed. We're repeating ourselves. And whenever we repeat ourselves, we want to try and refactor and make it better. And that's why, we're going to do this navigation object class. We're going to have the target, tile, and ship. We're going to put the ship in there, inherit from the navigation object class, as well as we're going to add the ship to the place scene to use that as a start point, add a heuristic enumeration to give us Manhattan and Euclidean options, make it possible to toggle this in IMGUI, create tile status enumeration, which gives us unvisited, open, closed, and passable and goal statuses or states, if you will. And then create a find shortest path method that, again, it won't be complete. It'll give us one path to display path nodes and the path length on the console for one path between the start and the end points. Okay, so that's what I want to try and get going with this. And we should have a lot of this done by the end of class. Okay, hopefully we get it all done. All right, but first, if I get you guys to download the starter, which is last week's Lab 4B, that's where we're going to start from, and then we'll go from there. I'm going to do the same thing, and I'm going to bring up the starter online. There it is. Lab 4 is Lab 4B. I made Lab 5A, and I'm just going to unzip this file that I downloaded from GitHub and go from there. So just unzip it. And we'll change this to Lab 5, what it's going to be, Lab 5B. And there we have it, Lab 5B. Now I can get rid of the zip file because I don't need that anymore. So Lab 5B, and I'm going to kick this off. Let's get going on this one. Again, I encourage you to ask questions as we go. But what you can do is you can put up your hand on the participants panel. That might be the easiest way for me to tell that you need help or that you need me to slow down or you have a question. I'll check chat as much as I can. I'm also live on YouTube right now, so there might be some people watching on YouTube. Again, you can use the chat on either location to get that going. All right, so first things first. Once we downloaded our project, I want to change this to x86. Just like we've done in the past. And I'm going to put this up on GitHub. And let's do that right away. So here's our project. I'm going to go to Team Explorer. But before I go there, Solution Explorer, I want to right-click on my solution and then add to or create Git repository. So what this does is it's kind of like doing Git init. That's what it does. Okay. So that's the first part. First part is making this a Git repository and then putting it up on GitHub. So I'm going to go to Team Explorer and I'm going to go to Home and I'm going to go to Sync. It's going to ask me to connect with Publish to GitHub. I'm going to click Publish to GitHub here. Now, for this lab, I've asked you guys to make it private. You can have unlimited private users on using your GitHub repository for free. As long as you're not an organization, you're good to go. And let's change this to George Brown. So if I was going to make it private, I would literally just click this button right here. But in order for you to share it with me, you need to collaborate. And I kind of went through some examples of that earlier today. Because there's so many of you, it would be really challenging for me to only have some of you collaborate with me, but not others, and then make it private. So we'll do some of you collaborating with me just so you can see the changes come up. We'll talk about it right now. So let's publish this, the GitHub repo. So again, it's on George Brown college, and it's going to be W2021 Lab 5B. Let's publish it. Actually, just to make it, I don't think I pushed the first one in, so I'll make it this Lab 5 as an example. Again, you can change the names as you like up here. This will actually produce the GitHub repository online. And then when we do so, when I go up on George Brown and refresh, then you're going to see that there is Lab 5. But I'd like you to start from your starter, please. Again, I'm looking for the starter as a place that you're going to learn from. I think it's a great opportunity for you. You know, starting from just handing me back what I give to you is there's no good value in that for you. So please don't do that. All right, so Lab 5 is where it's at. I'm just going to copy this, and that's going to be something that I'm going to update as I go. I'm going to just add a web link, and I'm going to call this Lab 5 Final. So again, Lab 5 Final is where this is going to go. Again, this is up on Blackboard inside the Lab 5 folder of the lab's content area. Okay. There we go. All right, so let's inspect what we have. Okay, so again, we're here, and let's run it, and we'll see what's going on. Some good things and bad things from last time. And again, part of what we're doing is making mistakes, learning from them, and making improvements slowly as we go. And then you guys can figure out how this whole framework works. When I was speaking with Alex earlier today, you know, we were talking about how many of you did really well, and we gave you a lot of the stuff to get your first assignment done well. And the hope is that you'll get to know how to use the framework and understand how to, you know, just how to program. I know this is probably some of your, for the first part, most challenging stuff that you've done in a while, and hopefully it'll get easier as you work. So here we are. So if I pull this up and if I turn the grid on, you can see that it currently calculates Euclidean distance. That's what it does. But this is no good. We want to switch this to Manhattan distance. We're going to do that today. That's one of our goals. Again, I can move this around wherever I want to. You know, as an example, I can do that and move it around. Yay. And what I want to do is when I click start, it's going to calculate the distance or the path from the start node to the goal node. But first, we have some issues, and like we do every time. And one of the issues we have right now, well, first of all, let's change our documentation. Here's our documentation. And we'll change this to Lab 5. So it should say Lab 5 now. There we go. +1. The other thing is, if I want to make you a collaborator up on GitHub, how do I do that? Some of you know how to do it already. Some of you don't. Let's try it together. I'm going to go to, like for this particular lab, GAME3001, Winter 2021 Lab 5. Let's make Alex a collaborator. I talked about that you need to make both of us a collaborator. Let's make Alex a collaborator. I'll show you how that's done. You're going to go to settings for your project, for your repository. And under settings on the left, you're going to see manage access. You're going to click on manage access. And here I'm going to put my password in. And once you put your password in, you're going to see who has access, right? And what you want to do is you want to invite teams or people. I'm going to invite people. So again, let's invite teams or people. And here is where I want to put in that repository, the repository link, right? So or the name of the person that I want to add in. And remember that I'm going to add in A. Richard 6 at georgebrown.ca. So that's the person I'm going to add in here, right? And again, if he has a repo, then he is, or he's got access here on GitHub, he's going to see that he's going to get an email. Sorry. Will you be updating GitHub? So far, the past few weeks, I've been just forking a repo and pushing to my own GitHub, but it says I can't make a fork repo private. No, you can't, and you shouldn't fork my repo anyway. You should download it, like I said, Nick, and start from scratch. It's just easier. So if I do this and click on A. Richard at georgebrown.ca, he'll get I can kind of give him whatever access he wants, read access or write access or whatever. So you can see that I can add him to this repository. He will get a request for this, right? And what's going to happen with this request is he can respond or not, right? And when he does, then he's going to get if I want to make him an admin, I can always change it. I can say, okay, I want to make him admin. So now with admin access, he can go into this repository and, he can do a lot of stuff in here. All right, so that's something. If I wanted to give him specific access to this, now he's already here, and I can create teams as well, which is what I've done here in George Brown. So that's one thing you can do. You can make as many private repositories as you want, and if you have a free repository, you can add in as many collaborators as you want. So there's unlimited number of collaborators. You don't need to worry about how many people you add in. So that's something to know. So yeah, so what, and the question was, what role should we give for you two? I mean, read access is enough. Ethan, I don't think that I need to really do anything in your lab. If I can read it, if it's private, that's good. I don't need much more access than that. Okay. Reading it means I can download it and check it out and all that kind of stuff as well. Okay, so that is who has access if I wanted to give collaborator access. But for the most part, this is a public repository. He just has access to do more admin work. If it was private, then he's the only one that would be able to see it. Okay, so that's how this works. All right, great. So now that I put things up on GitHub, I'm ready to do the next part. So we talked about this last time. One of the challenges we had last day was the game object we were using for our tiles and our ship and all that kind of stuff, or sorry, for our target. I mean, it had a lot of duplication. Remember, in our navigation, we had our tile.h, and our tile.h had get grid position and set grid position, right? It also had this grid position. And so did our game object, our ship. So if you look at, our target had the same thing. Get grid position, set grid position, and grid position, right? So it'd be nice if even the next one will need it as well. I need to make a ship that does the same thing as a start, right? So Ethan says the lab 5-star link is a link to lab 4, not lab 5. I'm not sure whether to start. Yeah, you download, Ethan, the starter, and then you create your own repository, right? And just like I just did, and you name it lab 5. So you're starting from lab 4, that's your starter. You make a brand new repository, you download it, you don't clone it. You make a brand new repository from that. You call it lab 5, and then that's the one you use. I'm going to share lab 5 with you. Lab 5 that I'm doing, the final version here, is for you to compare yours with mine to see if you did something different. It's not supposed to be for you to use this one. This is my final version, so you can see it. Okay, let's continue. So I've shown you a couple of places here where there's some duplication of code, and I also want to add the ship object in there, and it needs the same kind of grid position stuff. But instead of me doing it and duplicating it again, I think it's time for us to make a new class. So let's do that. I'm going to go into core. And again, I want you to think about us doing some small optimizations. I don't expect for us to do all the optimizations. We want to make this work, but sometimes, you need to bite the bullet and do what you have to do. So here in core, right, I'm going to right click and I'm going to add a new item. Make sure when you add a new item that you point your location to the proper place, which is the SRC folder. I'm going to the SRC folder in here. So that's where I'm pointing to. So it's in the SRC folder, not the template folder. If you go to the template folder, it won't find everything. I'm going to go to header, and I'm going to add the new header in here. And I'm going to call this navigation object because it makes sense. Navigation object is the name that I'm going to use. I'm going to click on add. So that's going to be the first thing. That's going to be in core. And before I even continue, I'm going to add in the other object, which is going to be the CPP file. So again, I'm going to call this navigation object .cpp, this one, in the same SRC folder, add, and then I'm going to include navigation object.h. You should be able to do this right off the top, okay? So what the heck is navigation object? Well, first we're going to say if not defined. We're going to use a little directive. This is a compiler directive. And in the compiler directive, we're going to say, make a little macro, navigation object. And then we'll define it as what it is, navigation object. And then end if defines, this is just our convention, navigation object. There we go. And then what we want to do is we want to do a new class that's going to be called navigation object. Same name as the file. It's going to inherit from, that's what the colon means, a public display object class. So it's going to inherit from display object. It's going to be like display object, but a specialized form, right? Which is going to allow the user to get grid position, set grid position, and maybe other things as well. We'll see if we can add into it today. So first thing I want to do here is, because I'm inheriting, I want to implement the missing members, generate missing members. And what I want to do is make sure these are set to 0 again. So void, and I want to make them virtual. So again, virtual void override is equal to 0, which is going to make this class an abstract class again in some ways, right? Because what we don't want to do is we don't want to, to make an object of navigation object directly, right? As an example, we want to make a class that inherits from navigation objects, so we can do comparisons between one object and the other. So the first thing you do is do one of these, which is going to make these lifecycle functions, which are inherited from display object. That's what they're from, right? They're going to be virtual. So these are going to be virtual things that our final class, which is our target, our tile, our ship, it's going to inherit from this class, okay? And then we need the constructor, right, which is going to be just the navigation object constructor, as well as the destructor. These are going to be pass-throughs, and maybe if I can show you what I mean in a second. So again, navigation object is going to be, there's a destructor, so constructor, destructor, and some objects plus a private area. I'm doing this all without implementation yet, just to scaffold it out, right? The private area is going to have a new GLM vec2 object that is going to be called m_grid position. Like we added in the other class. So this is kind of the structure. I'm also going to have a getter and setter area. So getters and setters. The first getter is going to be return a type of GLM vec2, which is going to be called get grid position. Okay. As the next one is going to be a setter, set grid position. These are all the things we've done before in the past, right? We can also copy paste if we really feel like it. But I'm just going to type it out so that you can catch up. So that is our header, complete. That's what I'm looking for right now. Are you with me? Check mark if you're with me. X if you don't know what the heck I'm doing or behind. Or if you want me to slow down, I can slow down. All right, hopefully you guys, Neil is an X. Neil, what's the problem? Or you want me to slow down? No. 30 seconds, no problem. Yeah, and I think the thing here is that I'm looking for you guys to participate and, kind of understand what I'm doing. I know, Sinan. But again, a lot of this is the same as we've seen before, right? So that's the first thing. So the first thing is you do the header. And the next thing, what you want to do is you want to, kind of expand all these, right? At least these ones won't expand. We don't care about these. We don't want you to do anything with these. But these we want to talk about. We want to define these, and these ones can be passed through, again, like we said before. All right, so let's do that now. Let's go into the navigation object, and then if you click on the little hammer on the left, if you're using ReSharper, then it's going to say generate definitions by declarations, which is going to bring up this little dialog box over here. And notice that there's everything that's selected. I don't care about doing these because these are not, I'm not going to create a definition for these virtual functions. These are just going to be an interface so that they're inherited from the objects downstream, which are the tile, the target, and the ship. These are going to be inherited. And then we can define these functions inside of those classes, because that makes more sense. Member function with override does not override base class member. You'll see. All right, so then after I've done this and I press finish, right, then it's going to define this. What I want to do here is I'm going to make these pass-through functions. Like I said, my constructor and destructor, they're not going to be doing anything physically here. The things that I do want to do are in here, okay, in here. And what I want to do in here are the same things we did last time, right? Remember? So what we want to do for this one is we want to return, for my getter, we're just going to return m_grid position, right? And the other one for now, all we're doing for now, we're not doing anything else in there, is m_grid position is equal to a GLM vec2 object that's going to give us our column and our row. That's it. So that is the only thing we want to make a change to right now. I do want to set these as const, so let's do that, because those are the recommendations from ReSharper. Okay, so that's where we want to start with. And that is our navigation object class. Okay, I'm going to put this up on GitHub now. So Team Explorer, I'm going to go to Home, I'm going to go to Changes, and I'm going to say that added navigation object class. Commit all, home, sync, and push. And you guys should have all that on that link I gave you on Blackboard. So you can always kind of compare mine to yours. All right. So hopefully that gets you where you're supposed to go. And we've got this piece. Okay, the next part is actually using it, right? So we've made our navigation object class, but I want to inherit it in my target and my tile. Let's talk about how to do that. So again, I'm just going to go to Solution Explorer and go to my target class. So my target class is here. And because they're going to be, target is going to be a navigation type, and so is my ship. I'm going to take the ship and the target and pull them into this little navigation filter. That's where they're going to be now. So I can close this down so I don't have to look at all these other things. It's a lot more cluttered when I do that, right? So I just want to look at these things. So let's start with my tile. So tile.h right now inherits from display object, but instead of inheriting from display object, because navigation object is a display object, if I inherit from navigation object, I also inherit from display object. So this is a specialized form of a display object that I'm showing you. So again, tile, I want to replace this with navigation object. And when I do that, it says, hey, do you want to include this? Yes, I do. And then we can get rid of display object reference. We don't need the reference if we already have navigation object, which inherits from display object. So that's number one. And because we did this, we don't want grid position here because we already have this inside of navigation object, or get grid position, set grid position. We don't need these here right now either. So let's get rid of those. And following that, let's go to tile.cpp, and we want to get rid of the implementations for get neighbor, get grid position, set grid position, which are red now. So let's get rid of those. So we can see we're already saving code. Not a lot, mind you, but a little bit. Okay, so that's a little bit of code saved. Yay, some code savings, fantastic. Okay, I want to do the same thing for my target class. So again, target, here's my target class. I want to inherit from navigation object. Okay, so navigation object, yes, I'm going to use that one instead of display object, get rid of that. And I don't need this here as well as all of this. There it is. That's my navigation object for my target. It's very simple. And my target.cpp, the same thing. I'm going to go down to this area here where I have my get grid position, set grid position. Get rid of those because they already exist inside of my navigation object, right? So that's it for the target. So far, so good. And finally, I'm going to do it on my ship because this is going to be my start position. So ship.h, I'm going to inherit from navigation object. Again, same thing. It's going to ask me to inherit from navigation object. Yes, good. Let's get rid of display object. And I have nothing else to do in this one because I never included grid position, get grid position, set grid position. I don't have to do that. One thing, though, I do want to change in my ship class, in my ship.cpp, because I don't want this to move right away. I want it to draw, but I don't want it to move. Then what I want to do is just comment out anything inside the update function right now. So in the update function of my ship class, let's comment these out so it doesn't move by default. Otherwise, it'll just move. And I don't want that yet. So save. All right, those are the changes I made. Let's put this up on GitHub. All right, so again, I'm going to go to Team Explorer. I'm going to go to Home. And I'm going to go to Changes. And you're going to see the files that were affected. I'm going to go here. I'm going to say had ship, target, and tile inherit from navigation object. Okay, that's what I did there. And then I'm going to click commit all, right? Save, home, sync, and push. And again, that's all up on GitHub now. All right, we haven't tested anything. We've just made a class and got everything to inherit from it. Hey, let's test out that by itself, it should just work. Okay, so if I run everything, and if we did everything properly, then let's see what happens. 1 sec, Neil. So one thing at a time. First, we just see if everything runs the way it was before. And you can see clearly that it still does exactly what the other thing did before. I can still move around my tile, my goal. That's my goal object, right? And everything else works the same. So if you're getting an error, and if it's saying, Neil says, it's saying that navigation object is not initialized in ship constructor. Okay, well, let's take a look at that. So first of all, navigation object.h has its own constructor. Remember that I've made a pass-through constructor. So there's nothing for you to do in navigation, the navigation constructor itself. In the ship.cpp, right? Remember that I'm by itself, it's inheriting from it inherited from display object before, and before that, it inherited from from the previous one and the previous one, and each one of those things was passed through. So it means that if I go and look at my display object in the core, if I go display object.cpp and display object.h, again, you can see that these are just pass-throughs, display object, right? And I will in a sec. And the same thing with game object itself. If I look at game object.h and game object.cpp, again, if you notice inside the constructor function, that it doesn't call anything else, and even the game object destructor is passed through. It doesn't really do anything. So it shouldn't be causing that problem for you. If you made the navigation object public, when you inherit it, you have to inherit from a public display object. This is the key, public display object, and make sure that your ship .cpp or ship.h is also inheriting from a public navigation object. Those two things are important. All right, so you're looking at navigation object.cpp. Sure, it's not much in navigation object.cpp. It just literally looks like this. It just has two functions, two getters, a getter and a setter, and that's it. Again, all of this is on GitHub. I encourage you to check your code against mine to make sure that you are doing similar things to me. Yeah, check your code against mine, Neil. Make sure that yours and mine are the same. Right? Remember, all the things I've only touched those things that I told you about, right? So hopefully you should be golden. Okay, and again, it could be like just a copy paste operation at this point, but you know, I mean, I want you to understand what I did. Like literally, I didn't do anything. I just inherited from, I made a new class navigation object, which just inherits from display object. That's what it does. And then I just pass everything through. It messes up my target.cpp for some reason. Kenny, I don't know why. You have to give me more information on that. All right, so and this should probably say Destructor, not something else, whatever I said there, Destructor. All right. Okay, so that is navigation objects. Hopefully you guys are almost where I am. Again, all I did was I did a couple things right now. And if I look at the PowerPoint for my goals, I did this part. So this is done, right? And after I did this part, then what I did was I had target, tile, and ship inherit from navigation object. That was done, right? And now the next part is adding the ship to the placing and use it as a start point. I'm going to do that next. Okay, I'm just waiting for a while. Please check your code against mine. Okay, hopefully that'll help you out. And the next question I have is, are you with me? Who's with me? Hopefully you guys are with me. I got Jacob, you're with me. Thank you. Dylan. And so far, just you two. Oh, I got a third person and a fourth person, Eric and Betty. Cool. And that. Ethan, I don't see you, but it's okay. Not on the participants panel. All right, and one sec, guys. What is that? What hose?
Was there a hose attached to the default?
The gray one?
Not the gray one. Is there another one?
The one that's there that you attached with me last night.
No. Was there another
No.
hose?
Nope. All right. Can we go back to navigation.h again? Sure, let's do that. Navigation.h is where we are. Hopefully you'll be able to see this. So again, remember that all I'm doing here is passing through, right? That's all I'm doing here. And hopefully you guys are up to speed with me. Okay, so now that I've got this, let's continue a little bit. I'm going to push through a little bit. And again, please check your code against mine on GitHub. That might be easier. What I want to try and do is I want to kind of add a ship to the scene. So again, I'm going to go to scenes and playscene.h first. Here's playscene.h. And just like I added a target before, I'm going to add a ship this time. So ship pointer m_p ship is what I'm going to call it. I'm going to add a reference. There we go. So again, all it's done is add a reference. Okay, so that's what it's going to do. And then after that, I'm going to instantiate it the exact same way that I did the target. So that's going to be in my playscene.cpp. Inside my playscene.cpp, if I go to the start, right? So let's go into, again, you can go out of scope here, go to playscene, and then jump to start. And inside start, you'll see that this is where I built or added the target to the scene, right? And what I want to do is I also want to add the ship to the scene, right? So let's do that. So again, we'll say, we'll add it first, add the ship to the scene as a start point. And this is the target to the scene as a goal, right? That's what that is, start point and a goal. So we're going to update that in a second. Let's do the same thing. So I'm going to say, one thing to note is I may need to use the offset again. So I'm probably going to just push this for now up a little higher. It doesn't have to be next to the target, but I need to use it because it's going to be the same thing, and we haven't fixed that problem yet. We will, but one thing at a time. So I'm just going to put a little higher up so I can use it for the ship as well. So I'm going to say that m_p ship, right, is equal to a new ship. That's the first thing. And then I'm going to say that m_p ship, and I'm going to get transform dat position is equal to m_get tile. Remember, get tile is our convenience function, right? And does order matter if I do it before the build? Well, build grid, you want to do it after the grid, that's for sure. Because the grid is going to do, I'm going to get the tile from the grid. That's what this little function does. So you definitely want to do it after the grid. The grid has to come first, okay? And I'm going to put it at, let's say, 1 and 3. So 1 and 3 is the position I'm going to put it at. And then what I want to do is I want to chain that to say get transform, just like we did down here, transform, and then position plus offset. And this is going to place the ship in the exact location of tile 1, 3, right? We also want to continue. I want to say m_p ship, and then set grid position to 1, 3. All right, so that kind of moves it physically in world space, and this puts it in the grid space. Now, it would be really nice if I had a function that did both those two things for me in the navigation class, navigation object class. For now, though, let's continue. And finally, add child. I want to add child m_p ship to the scene. Okay, so that adds the ship to the scene. This art added our goal to the scene. This is our start point. This is our goal point, if you will. And now, if we did everything correctly, was a lot added? No, just this. If we did everything correctly, and if I run it, let's see if I can do that, right? Then I should see two things, my ship on one side and my target on the other side. Let's see how that looks as I run. And then I'll push this up to GitHub again. Hey, this is what you should see. Ship over here, target over here. And if I turn on the grid, and let's just move this, I'm going to move this aside in a second. But you can see that it's exactly the same size as the grid tile, so it's not going to be outside the grid. It snaps to that grid. 1, 3, right? So whereas 0, 1, 0, 1, 2, 3. This is the position of where it is on the grid. This is the position that it is on the grid. Okay, those two positions. So that's what I did there with, by making the ship a navigation object, I'm able to use setGrid. Okay, not quite done yet. We're still going. We're going, right? Because these are some of the initial steps that we need to use. This is all set up right now for us to do pathfinding. Okay. All right, this is great. This is fantastic. But we still need to do some additional work. Let's put this up on GitHub. So again, Team Explorer, I'm going to go to Home. I'm going to go to Changes. And I'm going to say added ship to placing. And I'm going to commit all. I'm going to click Home, Sync, and Push. And you guys should have that too. Mustafa says it's telling me that that tile has no member function called getTransform. Again, the only reason that has perhaps happened, Mustafa, is if for whatever reason you did not include the display, navigation object.h. Okay, navigation object.h must be included at the top of your tile as an example, right? So if you look at tile.h at the top, you're going to see that I include navigation object.h. It must be done, and then I inherit from navigation object. Okay, so I kind of have those two things. And I removed display object.h. I don't need display object.h because it's going to be accessed twice. If I put it here and from here, navigation object inherits from display object. That means you don't need both. I have it included. I'm inheriting from it also. Yeah, not sure why that is happening. Check for other errors in your code. Or, like I said, please go up on GitHub and compare your files to my files. Check your files, see what your file looks like. The way to do that is to go up on GitHub, right? So here's GitHub. And let's say, for example, if I refresh, need to refresh, it tells you all the changes that I made and where, right? And so, for example, in the source, the SRC folder, if you go down to, you can see that all the ones that were done 2 minutes ago are the ones you want to check, right? So, for example, if I want to check way up on the top and I want to check navigation object.h, then here's navigation object.h. Worst case, copy paste, right? So you can do this, guys. You know, it's there. It's up online. Okay. Mustafa says Visual Studio was being stupid and I had to delete the word transform and type it again. Okay, not sure. Sometimes it does that kind of thing. All right. Fantastic. That's this part. It's done. And we've got our ship showing. Okay, now, so let's go back to our little PowerPoint and check it off. Add a ship to the play scene as a start point. Now we have to use it as a start point. We almost got this done. We got this part done, but not this part. And in order for us to do this start point stuff, we haven't done this yet, but one thing I have right now is the tiles. It's kind of a multi-step here, but let's just put this part. So add a ship to play scene, yes, we can cross that out, but not this part yet, okay? But we want to talk about the type of heuristic we're using. Right now, remember what we're doing is we're using the wrong heuristic. As per our lecture earlier today, I indicated that in our code, it says that for a, it really works well when we're only moved in 4 directions, right, left, top, bottom. This is where Manhattan distance works. And you want it to look like this, but we're not using Manhattan distance right now. We're using Euclidean distance. And the way to tell where that is if you go to your playscene.cpp, and if you scroll down, or if you jump to the compute function, which is my compute tile costs, this one, right? The way I compute tile costs, which is on line 220 for me, right, is I loop through each tile in the grid. I have this ranged for loop, and basically what I do is I calculate the distance for each tile. Calculating distance for each tile, my friends, that's Euclidean distance. So this way of doing it is Euclidean distance. Okay? But I want Manhattan distance. How do I do Manhattan distance? Do you remember? It's actually in the PowerPoint. How do I implement Manhattan distance instead? Instead of Euclidean distance, I want to implement Manhattan distance. How do I do that? Well, let's comment this out for a second, right? Yeah, there we go, Nick. Thank you. So let's comment this out and let's go right to the PowerPoint. So I'm going to go right to the PowerPoint and look, there it is right here. I want to grab this part right here, right? I want these two things, copy right from the PowerPoint on page 11 and go back to here and paste them and then put auto in front. Auto dx and auto dy. Auto means find whatever this thing is. And ABS is actually a function built into C++, math library. No.x, well, that is just where I am right now, which is the tile. So that is tile, and goal is the target. So tile, right? Tile.x, tile.getGridPosition is what we want. Tile getGridPosition.x and tile getGridPosition.y. That takes care of this part. And then mTarget getGridPosition, because we're going to use the grid position, not the world space position. Right, .x and .y. Again, I'm just taking the code right from the PowerPoint and modifying it to our usage. There we go, dx and dy. And then finally, we want to calculate the distance as equal to adding up dx plus dy. All right, so that's what the distance formula is. We'll make this auto just because. All right, so there it is. There's Manhattan distance. Yay. Okay, pretty simple. Let's see how this looks different than Euclidean distance on the grid. So again, if I run it, and if I see what the grid looks like, so turn the grid on now, you'll see that it is whole numbers. That makes sense because I'm counting tiles here. That's what I'm doing. I'm counting across. Let's take this away And in order for me to move that, by the way, it's a little bit annoying, but I have a bit of a bug still that I haven't been able to get to. I'm going to go here where it says in IamGUI, where it says IamGUI window flags no move. I'm just going to take this away so we can move that window around. That is on my line 96 of the GUI function. Okay, just moving that away so that way I can move that little window around. So if I run it now, Ethan says we don't need double floats for them anymore. I'm not sure what you mean there. Hold on. So yeah, if I move this, then you'll see I get a bit of that weird stuff. But if I put it back, it's back, right? Just need to update that. Okay, so now if you notice, if I still can move this around, right? And if I show the grid, it's in whole numbers for the most part, right? So you're going to say, can I take away? Is that what you mean, the floats? No, we're going to put these back, leave them in, Ethan, because what if I want to switch and I want to from Manhattan distance, the Manhattan heuristic to the Euclidean heuristic, which I'm going to get you guys to do now. How do I do that? And I want to be able to switch to different heuristics depending on, you know, my IamGUI switch. Let's make this lab 5. There we go. So I want to make use of a radio button. A radio button is a little dot basically that allows me to select, you know, which one I want to use, right? And so I want to enable that functionality, right? We could create a way that displays the decimals depending on if it has to display. Sure, you could do that too. But for now, let's do this. What I want to do is when I compute tile costs, it depends on the type of heuristic that I'm using. And so that means that I need to have a current heuristic or some kind of way of selecting a current heuristic. So I'm going to go back to my placing.h and I'm going to add in kind of a current heuristic thing. So it's going to be something called a heuristic. Right now I have one or the other. I have to hard code it. I don't want that. And I want to create an enumeration to help me. So I already have it, by the way. It's also, you already have it. All you need to do is go to enums, right where it says enums, right click, and then I want you to add existing item, please. Go click add existing item. It's already there for you. And if you look inside the right folder, which is inside the src folder, then you're going to scroll down to where it says heuristic.h. Please select heuristic.h and click add. And it's going to add in this file, Manhattan Euclidean. Okay, it's already done for you. So again, you just go to do that, you go right click and you go add existing item. And then you have to point to the src folder and you want to select heuristic.h and click add. Okay, that's how I got that. All right, so this heuristic.h is a way of us switching or keeping the state of which heuristic we're in, where it's Manhattan heuristic or Euclidean heuristic, as an example. And you can have other ones, the null heuristic, you know, the different kinds of heuristics that you want in here as well, or you know, the diagonal heuristic, whatever you want. Okay. I'm going to go back to my placing.h now and make an object of that type. So I'm going to say heuristic, right? And it's going to be called current heuristic. And it's going to ask me to include heuristic.h. And I'm going to say yes, please do. So heuristic is going to be the it's going to keep track of my current heuristic, which is it Manhattan or is it Euclidean? Okay. So this is going to help us switch between one thing and the other thing. Wonderful. All right, cool. I like it. So far we're cooking, right? I'm going to go back to my placing.cpp. And what I want to do is in my start function, so I'm going to skip to the start function, which is around my line 61-ish area. I want to, after I set the placing and build everything, before I do my calculations somewhere, I want to set the heuristic. So maybe after offset, doesn't matter where, something like up here. I'm going to set the heuristic. So I'm going to say that current heuristic, right, is equal to some kind of heuristic, and I can decide what it's going to be. Maybe by default, I want it to be Euclidean. Okay, there's Euclidean by default. That's what the heuristic is going to be, right? And that's fine. I'm perfectly fine with starting off as with Euclidean heuristic, right? And what I want to do now is, depending on the heuristic that I'm using, it's going to calculate tile costs based on that heuristic, okay? So what I want to do then is I want to switch between the 2 or 3 that I have. Let's go there. So go to definition, and inside of here, inside of my little loop, first of all, let's define some variables up here. So I'm going to say a float, because I can't have distance defined twice. I'm going to define it up here. I'm going to say float distance. I'm also going to define x, dx, and dy up here. So float distance, dx, and dy. That means I don't have to do them down here. Okay, so just get rid of those. Okay, distance, dx, and dy. I can bring this back. So distance can be either a distance for Euclidean distance or this kind of distance for Manhattan distance, and I want to switch between these two things, which is exactly what I'm going to do. I'm going to use a switch case. I'm going to switch it with current heuristic, and basically what I'm going to say is case Manhattan, then do something, case Euclidean, then calculate something else. Okay, so that's what I'm going to do there. I want to pass the Euclidean piece inside the Euclidean area right here. And I'm going to pass the Manhattan piece in the Manhattan area up here. And then I'm just going to take away some spaces, and that is going to be the way we switch. So we switch between one type and the other based on the enumeration that I set up. And that is compute tile costs so far. Okay, a good check for you guys. Are you with me before we move on to the IMGUI piece? So I want to be able to switch between one type of object and another, and I also want to be able to move my start around as well. Okay, hopefully you guys are with me. I got one check mark. Thank you. The rest, no one's answering, which means either you're not with me, or you're watching, or you're trying to catch up. Jacob says no. Okay, mine is not now showing up. Question mark. Can you put it on GitHub real quick? Dylan, Ethan, I don't think my reactions show up. Okay. George is catching up. Catherine's, the reactions don't work for me. I'm sorry, put a check. And Nick says, yeah, the same, and still trying to fix my problems from earlier is Kenny. All right, let me put this up on GitHub then. So I just I modified my compute tile cost method. I'll put that on GitHub. So home, I'm going to go to changes, and I'll say modified compute tile costs method and placing to work with different heuristics. It's too long, this line, but anyways. And commit all, and I'm going to say save, right? Home, sync, and push. Now that's up on GitHub too. All right, so hopefully you've got that going. That's the one thing I made a change to. So again, all I'm doing here is I'm just changing the type of heuristic based on the current heuristic choice that I have. Right now, it's always going to be Euclidean because I don't have a mechanism to switch to Manhattan yet. But I want to switch to Manhattan, and I want to do that with IMGUI. And let's do that now. So let's go to IMGUI. It's IMGUI section, which is up here. Right, so this is GUI function, which is around my line 86. And I want to think about where I'm going to put that. Okay, so remember that I want to create some kind of switching mechanism. I could use a checkbox, but I think a radio button would work way better than a checkbox, right? So what I want to do is underneath the current checkbox, which says grid enabled, I want to have a separator, and then I want to put a radio button. But I want to have a temporary radio button itself. So I'm going to say auto radio is equal to, we'll do a static cast, and we'll static cast, int to my current heuristic. Whatever my current heuristic is, I want to convert it from an enum to an int. Because the radio buttons in IamGUI require integers. So that's the first thing I'm going to do. And the next thing I'm going to do is I'm going to say, hey, IamGUI, let's make a label to say what this thing is. I'm going to say label text is, let's make it so that it is going to be heuristic type. Okay, that's what it's going to say. A little label on top. Notice that there is an extra quotation. This actually is a spacer. Let's go back. And then what I want is IamGUI radio button. My radio button is going to be called Manhattan. And it's going to say and radio, and it's going to start off with 0. 0 is equivalent to my type. I could, if I really want to, cast my heuristic to this to make it more apparent. So in other words, 0 is this, if I hover over, and Euclidean is that, right? 1. So if you really want to be technical, you could change this out so it says Manhattan and convert it to an integer. So I could say something like int, which is Manhattan, right? That's what I want to do. So you can see that it's a Manhattan type. And if sometimes it also say, do a static cast. I'm okay with static cast, whatever, if it makes you feel comfy. Next is IamGUI, right? And then radio button, another radio button, right? And the radio button that I'm going to put in next is going to be called Euclidean, right? And it's going to have and radio again, right? And then we'll do a static cast of int, and we'll call this thing Euclidean. So you can see that it's Euclidean that I'm getting. I need a little, another little spacer, which is IamGUI, same line, because I'm going to put them next to each other. Okay, and that is my radio button. It's going to show up in IamGUI, but it needs to do something, and I'm going to check it by doing something that looks like this. I'm going to say if my radio, right, or let's start like this. If my current heuristic is not equal to, let's cast radio as a heuristic, and we'll cast it as this, right? If my current heuristic is not the same as the one I have in the radio button, then what I want to do is my current heuristic is going to be equal to my radio button. Whatever the radio that I've chosen, the radio button, one of the two buttons that I've chosen, I'm going to make the current heuristic equal to that. And then I want to recompute Tilecasts. Why? Because I've switched the heuristic. And once I switch the heuristic, I want to recompute. So that is the thing that's going to add some functionality to IamGUI to allow me to do that switch. Single equals. Yes, thank you. And if I run it, then you should see it has a little check mark. One thing that I'm missing is a separator. I might put a separator between this and the target position. And I'm also going to make a start position in a second. So again, when you look at it, if I press, if I tab this out, and you can see that I have two choices now, Euclidean and Manhattan, right? That's what this does. Okay, and if I show you the grid, it's a little messed up. If I go to Euclidean, everything shows up. If I go to Manhattan, it shows like an overlay. But if I bring it back, it clears it up. So again, there's a little glitch I have to fix. But notice that when I go to Manhattan again, it's all kind of whole numbers. And when I switch to Euclidean, it's all decimal places, which makes sense. Now I want to move my ship around. If I can move my ship around, that would be great because that's going to be my start point. This is going to be my goal. All right. So that's good. That's my separator. And let's put another separator underneath the radio buttons. Okay, there's my separator underneath the radio buttons. And then I have this big space right here for target position. Let's just copy this whole spot and make another slider for my, or a group of sliders for my start position. So let's just rename this target position to start position. Don't worry about the red. We're going to get rid of it. Start position is going to be something where I put target position. Just copy paste. Could I make a function for this? Yes, I could. Not going to do that right now. So start position is the first. Let's call this start position. And this is target position. And then, of course, it's not going to be the target that's going to move. It's going to be the ship, m_p ship. And that means I get to replace wherever it says target in this block with ship. So I could do a selection, but I'm just going to do it by hand so you guys can catch up again, hopefully. All right, so that is my start position and my ship start position from the grid. And I'm going to move the ship around. And I don't need to compute tile cost when I move the ship again, because that is not something I need to do. That's only for my my target. My target needs to recalculate tile cost when I move my target around, but not my ship. My ship maybe recalculates the path. All right, that's what I might do. All right, let's see if this works. So can I move my ship around now? So again, bring up IMGUI. And I'm going over here, bringing this up. Now you see I have two parts. I have a start position and target position. I can move my ship around, right? As well as my target position around, right? And I can decide on the heuristic type that I want to show on the grid. Pretty good. Getting there, right? Okay, let's put this up on GitHub. So show 111. Here it is, same line. So again, I want to go to my Team Explorer, go to Home. I'm going to go to Changes, and I'm going to say added heuristic toggle to IMGUI. I think that's good enough. I'm at all, Home, Sync, and push. All right, and I also added the ship, but it's okay. Okay, again, so are you with me? Do you have that same kind of functionality working in IMGUI? Again, all I'm trying to do is show you how I can use IMGUI to control my interface and to make it easier for me to debug, because that's really what we want to do at the end. We want to be able to debug, right? So is the pathfinding working properly? How do I know? Well, I don't know, but I gotta show it. I gotta see what I can do, and then hopefully that'll work its magic. And I show compute distance. Show. So let's do that. So I'm going to go to the compute tile cost function. That's what people are asking. There it is. Again, not too difficult. I can add other ones in here too. I'm not going to at this point. But if you had other kinds of heuristics, let's say, for example, you were going to use the null heuristic, or you're going to use the diagonal heuristic, or you're going to use, best first search, whatever you're going to put in there, you can use different heuristics to do the same thing. Or hell, even if you wanted to use Dijkstra's algorithm, you can swap out what we're doing here with Dijkstra. Just so that way the heuristic, the calculation would be different than this, but it would be more involved in this, because what we do with Dijkstra is we do kind of cost as you go. All right, so that is the compute tile costs thing. And if I go back to here, and if I go to my little lab, we've done this part and this part right now. Still haven't done start point yet, and we haven't done tile status, which is what I'm going to add next. So I have this, but I want to be able to remember the way that my PowerPoint works. I want to follow my my pseudocode here. It says, hey, somehow I want to make an open list and a closed list, And I want to be able to mark this as open or closed or visited or impassable or whatever. So before we even do the pseudocode, we need some kind of status or state, if you will, for each of the tiles. To help us with that, I'm going to, again, make another enumeration. I'm just going to call this tile status. All right, you can call it tile state if you really want to. Same kind of idea. So I'm going to make another enum. So I'm going to add another new item. It's going to be of a header type. It's going to be in the SRC folder, and we're going to call this tile status. You can also call it tile state, but let's leave it like this. Tile status. Tile status, right, is going to be very similar to what we've seen before in enums. We're going to if not define, and we're going to go tile status, and then we're going to define tile status, and then indif define tile status. Yeah, this is just a convention we're using. Again, your coding house one day may not use something like this. They may decide just to use pragma once. So we're going to call this tile status. That's the enum. It's going to be a few of them. Okay, let's talk about them. I want to make one that's unvisited. I also want to have one for the open. It's an open tile. I want to make one that's closed. I want to have one that's impassable. I also want to have one for the goal and for the start. Okay, so those are all statuses, if you will. Okay, we can have other ones too, but these are simple. Like, for example, I can have another one that is, gives us a different tile status that it's open, but it's something else. Or instead of impassable, it's difficult terrain, right? And if it's difficult terrain, then it has a different tile cost. Who knows? It's up to you. All right, so that is our tile status enum. Let's put that up on GitHub. So I'm going to say Team Explorer, Home, Changes, and I'm going to say added tile status enum. Commit all, home, sync, and push. This is just giving us, again, this is all prep. All we've been doing here so far today is prep for the last hour and a bit. Why? Because I know this is what I need to make this work. That's why, right? And I'm trying to make our life easier, to try and get going. I'm giving you some structures that are very common that you can use to improve your your success chances when it comes to doing assignment number 2. All right, cool. We made a tile status, but we need to use it. And in the tile, I want to modify my tile now to add a tile status. Okay, let's do that. So again, Solution Explorer, I'm going to go to my tile. That's inside of navigation filter. Here's my tile. And what I have right now is a cost, right? And I have a cost label and a status label. That's going to display my status. But I need a status itself. And I'm just going to call this tile status. So tile status, that's the type, enum, and m_status is what I'm going to call it. Let's add in an include for tile status. There we go. Excellent. So tile status, m_status is what it's going to be, right? And you can see that I have get neighbor and set neighbor. I get tile cost, set tile cost, and guess what I need? Get tile status, set tile status. Let's do that too. I'll put them right here. So again, get tile status. It's going to return a tile status. I want to be able to check to see what the tile status is. Is it open? Is it closed? What is it? Get tile status. And I want to set tile status. Void set tile status. This is in the tile function, the tile class. And tile status, as an example, is going to be a status. So get tile status, set tile status. All right, again, all I'm doing is making a getter and setter for this new thing. Let's implement these. So I'm going to go here and I'm going to go to generate implementation. It's going to take me here and get tile status and set tile status, wherever it may be. Oh, did I do the other one too? Maybe not. Hold on. Let's implement the other one too. Not target, tile. There it is. Let's do this one. Sorry, I forgot to do this one too. There we go. That's both of them. All right, so what does get tile status look like? So I can get and set, right? Get tile status is pretty simple, right? It's the easier one. So I can say something like return, m_status. So whatever the status is, I'll let them know. Here's the status. My setter is a little bit more complex. And what I want to do is I want to say m_status at first is equal to status. That's the first thing I want to do. But I also want to change the label that's showing in the tile to show the status, a C or an O or an I or something that is representative of the status in the UI so I can keep track of it. Okay, so let's use a switch case for that. And we'll make it on status. And what I want to do is have several cases. So case, let's say, unvisited. If it's unvisited, then I want to say that m_status label, and we'll set the text of the status label to --, which is what we have already. Okay. Break. Case open. If it's open, then m_status label, set text to the status label. Oh, I want to make this O for open. Break. Okay. So those two things, unvisited, open. Let's finish this off and I'll go back to the other thing for a second for some of you who need it. So closed, just copy pasting now. Closed is going to be C for closed. We're going to show C. And we're also going to do impassable, which is going to be an I. If we have any impassable tiles, we don't have any yet. And finally, our goal and our start. Case. Actually, just copy paste again. Here's our goal. And we'll make this a G. And we'll also put our start as an S. So this is all encoding just so we can see it visually. Now, you know what would be really cool? If I had some little icons that I could use or some little textures that I could, kind of use here instead of characters. That'd be awesome. But then you'd have to know what those things meant. And so this is kind of a very simple way of displaying the tile status for all the stuff you're doing. We can make this const. Let's do that. So we'll say this is const, right? And that is set tile status and get tile status. I'm going to put this up on GitHub. So again, I'm going to say home changes. I'll say added tile status to tile class with get and set functions. Commit all, save, right? Home, sync, and push. So you have those two. Lots and lots of commits that I'm pushing up for you guys today. So that way you have a chance to look at this. Okay, cool. So now that you've seen all this, these are the different statuses that the tiles are going to show when I change status. Okay, this is all, again, still prep. It's just to make sure everything works, right? So I have a way of displaying my stuff, okay, in the class, on the interface. Okay, are you with me? Check mark. I'm just slowing down here just so you can see this. Check mark if you're with me. X if you're not, right? Or if something is still failing or whatever. And by the way, I'll stick around afterwards to help people who have issues. If there's people who have issues with their code, something didn't work, I can help you troubleshoot. Thank you for that. A couple people that responded. And I know some people can't respond because I'm not picking up the check mark or whatever, but thank you for that. All right, cool. So awesome. All right, we got this part done. And we go back to our PowerPoint and let's check it off. So again, going back all the way to the bottom, we can't do this yet. We haven't done this yet, but we've set up this. Okay, we set this up. We're almost there. We're almost ready to actually do pathfinding, right? I know it's crazy, but this is all the stuff we have to do to set up for everything we need to do, right? All right, cool. That's excellent. Let's go back now to our placing.cpp. So again, placing.cpp. Placing.h is here. We're good. We need a couple of things, but first let's go into our placing.cpp and modify stuff in the start function. So again, one thing to note is when we place down in our start function, so let's go in our start function. When we place down our target, right, then what we want to do is we also want to set the goal for this target. The tile, whatever the tile that this target is sitting on, we want to change its status to the goal, all right, because we want to be able to check to see if it's the goal tile. So I'm going to say m_get_tile, and I want to pass in 1511, which is the starting position of the goal tile. And I want to set tile status now, because I've been able to do that. I just made that function to the goal. All right, so that's going to actually show G. If you could see underneath, if you could look underneath the target, if it wasn't rendering, you'd see a G there. And we may decide to check or uncheck. If I don't want to see the ship or the target, I can take those away, maybe with the UI, some kind of toggle that I can create so I can hide those. I want to do the same thing, the same kind of idea. I want to do the same thing with my start. So instead of 1511, it's going to be 13, right? 13, and this is going to be the start. So start and goal. But we know that every time I move my goal around, because I can do that with IAMGUI, right? I can move my goal with IAMGUI. Then I need to update my goal, and I need to remove my goal from where it was. All right, let's go back down to IAMGUI, where I do that kind of movement, and that's in my target position. So whenever I move something, my target position, right, as an example, then there's some switches that have to be made. So I do target position 0, target position 1, and then I need to reposition my goal before I compute tile costs. So let's do that. So we'll say m_get_tile. And in order for me to get the tile, I want to get the grid position as an example. But guess what? My tile only takes column and row, and my get grid position, right? Get grid position returns a vec2 object. And wouldn't it be nice if we had an overload? Let's make an overload. So we're going to make an overload function from m_get_tile as a convenience. In order for me to do that, I'm going to go to my placing.h, and where it says my get tile, right now it only takes column and a row, and I'm going to change this so it takes GLM vec2 object. Okay, so it's basically an overload, different than an override, right? Hey, this is a good question for you on the test. You should already know about. What's the difference between an overload and an override? Get tile, and then GLM vec2, and then this is grid position. That makes sense. So I'm actually, instead of me using column and row, I can also take a vec2, which is what get grid position does for me, right? Nick says overload is multiple functions with different params. Override is unique definition for child class. Absolutely. The other way you can think about it, Nick, for an overload is it has a different signature, but the same name for the method. Same name, different signature, which means not only what it returns, but also the parameters. Overload. All right, let's make this overload happen. I'm just going to implement it. And it's going to be the exact same thing as this, right? The exact same thing as this other one. But we're going to do a few things a little differently. So I'm not going to change this part at all. This part, this return is going to be the same. I'm just going to define what row and column are. I'm lazy. So const auto we'll say, and we'll make it so that the column is equal to the grid position dot x, and const auto that the row is going to be the grid position dot y. And that takes care of this. So now it'll take either a column and row or a vec2. Nice little convenience that allows us to pass in the grid position, right, as opposed to breaking it out into its column row, and it makes it for us to write code a little bit shorter. Let's also make this const. And there we go. So that is mGetTile. There's two, right? There's two different types, two different signatures, two different overloads. We can make 5 different overloads. Maybe we can also take a vec3 for some reason or something else. Who knows? Or maybe just x and y coordinates, not just column and row. Okay, so that's cool. We've got these two little things. Let's skip back up to where we were working, which is inside of my IamGUI function. So again, I'm going to go to the GUI function, right? And the GUI function down where I'm modifying my start position, right? Now I have a mechanism for me to take a GLM vec2 and not just x and y coordinates from column and row. So what I want to do is here, I'm going to say something like, hey, getTile, m_getTile. And now notice I have this little down arrow, and the little down arrow tells me that there's two functions. I can take a vec2 or a column and row. And in here, I'm going to say m_p target get grid position. Get grid position returns a vec2, right? So I'm getting the grid position that my target's in, returning it to the tile, and then I return the tile pointer that I want out of it, which is something that I want to set the tile status to the new goal tile. So that's what I want to do here. But if I can do this, I need to also unset the one that we did before, right? So in other words, before I switch positions, I want to unset the where it was set to goal. I want to set it to unvisited. So again, let's just do the same thing here. And just after the renderer, where I clear everything, I want to set this to unvisited, right? So the current position, before I move it, I want to reset it to unvisited and then put this as goal. Hey, if I can do this for this, then I can do this for my target, for my, that's my start position. Oops, I did it for the wrong one, but actually I'm going to need to do it for both. I just did it in the wrong spot. This should be ship, and this should be start. And I'm going to do the same thing for my target now, because this is where it belongs. I just did it for start, but it doesn't matter. It's the same idea. So here, I'm going to just take this part here, copy. It's going to go underneath here and paste. And this is going to go from here. And it's so similar, you're going to say, Tom, it's screaming for a method. You're right. This is an optimization we can make later. All right, so this is going to be mTarget. And this will be unvisited and goal. There we go. Sorry about that. Hopefully it's not confusing. But those are the two functions. Those are the two pieces. So this is for when I move my ship around. I want to say the start is going to be different. And I want to clean up the start position, right? And when I move around my target, it's going to set my goal to where the new position is going to be, but make the other part unvisited again. So it'll uncheck the other part. Ethan says, what if you move goal off of a impassable? Wouldn't that convert an impassable to unvisited? Yes, if it allowed you to do that, but we wouldn't want that to happen, right? So we'd have to make rules to stop that. For now, there's nothing like that. So in other words, we wouldn't allow you to move to that. If you skip to that, it would skip to the next one, before or after. Actually, if anything, if we were going to procedurally generate our graph, which is something that we're going to do eventually, then once you changed any one of these things, it would just respawn all the obstacles. Sinan says, how to connect getter and setter status. I'm not sure what you mean, Sinan. I've kind of put the code up on GitHub, so I'm not sure what you mean. All right, so let's side by side. These are side by side? I think, are you asking me to, to make methods? Line 136, m ship, set tile status to start. Okay. And why am I doing something wrong? Okay. M get tile, M target, get position, set tile status to goal. Oh, how am I doing that, you mean? This part, how connect with get tile? Well, we don't, right? Get tile, remember what get tile returns. Get tile returns a pointer to a tile. So you can look at this whole thing as a tile then, some tile pointer, right? You don't look at this thing as get tile, you look at it as a tile, because that's what it's returning. It returns a tile pointer. So if I get a tile pointer, then whatever that tile is, then I'm going to set the tile status of that tile that this thing is returning to start. Make sense? So don't look at it as get tile. Look at it as what it's returning. It's returning a tile pointer, and I'm modifying that. I know, I'm so sorry. I know it's a lot. All right, so this is good. Let's check this out and see if it still doesn't break anything, because we don't want to break anything here before we move on to the next piece. But there's some good points that are made. What about if I move the unvisited on top of a, a current tile or whatever? That's tough. So again, if I go to grid enabled, and you can't see it, but there's actually underneath this thing, there's actually a thing that says there's an S in here, and there's a G underneath this thing. And if I move them around now, it just changed it back to a, what it is. So I can move these around, and it doesn't leave behind a G or an S. All right, but it changes the status, which is what I wanted. Okay, cool. So this is great. I'm able to change the status, which means I satisfy this requirement finally. All right, this requirement right here, I satisfy this requirement. Right, so this is done. Now, finally, at the end, we're going to do find shortest path. And this is where we're going to spend the remainder of our time. Okay, how do I do find shortest path now to show how this works? Whew. Well, we need a couple of things, right? And here are the requirements. One of the things we need is an open list, and another one, it's a closed list. Make a radio that hides, shows the target and goal. Yes, you could do that. Or some kind of checkbox actually is better, Ethan. And you can put that actually in the same, same area there with a little eye or something. Anyways, let's continue. So I'll let you do that stuff. What I'm going to do is I'm going to look at this pseudocode here. So the pseudocode says, here's A star. Initialize the open list, initialize a closed list. Okay, we don't have an open list and we don't have a closed list. Let's make them. So again, going back to our code, I want to go to our placing. Let's reduce some of this stuff for now. I'm just going to close the stuff we don't need. I don't need display object. I can get rid of that for now. And I can get rid of tile status and ship. I don't need ship. I've already modified these things. Target, I don't need. Tile, I may need. So let's keep that open. And navigation object, I don't need for now. So let's start off with my placing.h, right? Placing.h. And placing.h, what I want to do is I want to have those open and closed and one pathfinding list as well. So let's make some open, closed, and path lists. Those are the three things I want. So I want to make them all standard vectors for now. We don't care if it's inefficient. I just want to make it work. So I'm going to say m_p, and then this is the open list. And then standard vector of type tile, m_p, closed list. Open list, closed list. Standard vector of type tile, right? m_p, path list. So this is the path list that I'm going to get from the open and closed list. Do I need all of these? No. I can probably optimize way better than this. This is terrible. But it's a good start. We start big, always start big, and then kind of come, make it better, make it better, make it better. And why do I prefer that? I just think it's a better way to go. Is it the only way to do it? No. Let's make a new a pathfinding function called m_find shortest path. And this is where we're going to do all of our pathfinding in here. So find shortest path. I want to generate implementation, which is going to be empty right now. And what I want to do is follow the pseudocode as much as possible from the book, right? From the PowerPoint, actually. Okay, so what is step one? So step one, we were told that we want to add start position, whatever that is, to the open list. That's what we want to do. So let's start off with a tile. And I want to start this off by adding it to I want to break down to 2 lines. I don't have to do this. I can make it in 1, but I'll just add it to the, thing. So I'll say auto start tile. We don't have to use this. I'm just using it to make it easy to read. Is equal to m_get tile. And I'm going to pass in, that's why I'm using it again. I'm going to pass in m_p, and this is the start. Ship, the start is the ship, and then get my grid position, whatever that is. So whenever I call find shortest path, I'm going to get the grid position, and then I'm going to store it in the tile of where the ship is. Whatever the ship is, the tile that the ship is on, I'm going to return a pointer to a tile and store it here in start tile. Step 1. Then what I want to do is, and I could have done this in 1, I want to set my tile status. So I want to say, hey, start tile. Let's set the tile status, and I did this in 1 before, to open. So this is kind of what I could do, start tile, set tile status open. Or like I did before, Sinan, just for you, is I could take this piece, because this is the tile, and I can set this whole thing to open. Okay, so that's really what I'm doing. So now that the tile status is set to open, I want to add this to the open list, right? So I want to say that m_p open list, right, dot pushback, and I want to push back this start tile. That's how we start. So start tile is the thing that I'm going to push back on the open list. Start tile. And why is this not working? Oh, because I'm doing this. I'm doing too much. See? I was right the first time. See, this is where you can't combine. There we go. I was right the first time to break down. I mean, I can do it different ways. There's other things you can do to pass a reference to the tile itself when it comes out, right? Set tile status. I can make tile status return the tile as well. And then this would work at the end. It's almost like a chained, method chaining as opposed to the way I'm doing it here. But this is what I want. You want to take the start tile and push it back to the open list. Okay, so this is the first thing. Step 1. All right, the other thing I want to do is I want to make a little Boolean, because if you notice what it says, right, in the thing, it says, while the open list is not empty, right, and when the goal is not found, right, that's the thing. When the open list is not empty and the goal is not found, then I want to stop. The goal is found, or if the list is empty, right, then I want to stop. One of those two things. So let's put that in. So step 2, loop until the open list is empty or the goal tile is found. Okay, that's step 2. I'm just bringing it down for you, right? So I'm just literally following the heuristic or the pseudocode. So that would look like this. While And again, we could use a Boolean for the goal tile. I can make a little Boolean that says my goal is found. Let's say my goal found is false for now. All right. Let's assume that when we start this off that I've just put a tile on the open list, right? So for now, we don't care about if the open list is empty, but I could check for this, right? If either the open list is not empty, or I can also check to see that the goal is found. Either one will stop this thing. So if the m_p open list, right? And if I look at empty, right, that's empty. If it's not empty, if the open list is not empty, or right, goal is found, right? Goal found is not true. So it's or it's not, the goal has not been found, right? If the goal was found, then it'll stop this. Either one of those things. If they become true, if goal is found, or if the list becomes empty, this whole thing stops. Okay, that's our stop condition. By the way, you can write this recursively too. All right. Can we store same tile in different vectors? Absolutely. All we're doing is storing references, synen. We're not actually storing the real tile, just references, pointing to the same memory location. All right, I want to start off by checking the I want to find the minimum tile, right, from the neighbors. So I want to say that I want to make auto min is equal to infinity. I want to start with minimum is infinity, the biggest value possible, right? And then I want to have a couple of additional helper things that we're going to make here, okay? A couple of additional helpers. One of them is a tile pointer that's called the min tile. The min tile is going to hold a reference to the tile with the minimum value from the neighbor tiles around the start tile, whatever the start tile is. Okay. Now, because the start tile has been added to the open list, then we can refer to it as open list, and we can use the list as 0. But what I want to do is I want to get a list of neighbors. I want to get a list of neighbors so I can loop over them, for loop over them. Except my neighbors right now in my tile.h are not it's not a vector, but actually it's an array. It's an array, right? So what I want instead, right, in my placing.cpp is there's two possibilities. One, I can make a neighbor list based on the array, and I think I'll do that. But I need to loop over, kind of make a for loop that loops over each of the neighbors. So I'm going to make a temporary neighbor list, if you will. All right, so I'm going to say that I need to make a standard vector of type tile pointer, which I'm going to call neighbor list. Okay. And this neighbor list, I'm going to push back stuff. So I'm going to say for, I'm going to do a for I, where my counter is, my index is the, it's going to start at 0 and go to the number of tiles. So notice that, remember in the tile.h, we have this number of neighbor tiles. Because I don't want to, maybe I'm going to have 8 tiles in the future. I don't know. So that's going to be the upper number of neighbor tiles. That's an enumeration again. So I'm going to loop from each one of these things. And then what I'm going to do is I'm going to say neighbor list, right, dot pushback. And I'm going to push back the object, right, as an example, the neighbor, get neighbor, right? Remember what I can do, right? I can get the current tile that I'm looking at. So that's the, in the open list, the one I have in the open list. So m_p open list. I'm going to look at the first tile in the open list, which is the only tile right now. I'm only ever going to have one tile in the open list, right? And then in the open list, I'm going to get neighbor tile, and I'm going to pass in the neighbor tile position as an index that I'm going to cast as neighbor tile. So I'm going to say neighbor tile index. So that is going to basically say that I'm going to push back each of the neighbor tiles that I'm getting inside of a temporary list. I'm just doing this for convenience, not because I need to do it. I can use array, kind of a simple way of looping through each of the array objects as well. And I could go through each of them and not even use this piece. This is just a redundant piece right now that I'm using just to make our lives a little bit easier to look at maybe later on. Backing up, I also need some kind of integer that's going to show my min tile index, which I'm going to set to 0. And I'm also going to have a counter that I'm also going to set to 0. You're going to see all these things and how this ugly code is going to knit together in a second. Okay? So now that I've got a neighbor list and it includes all the neighbors from the current tile, the one that's inside the open list, right? What I want to do is I want to loop through for each of the tiles in the neighbor list. I could have done it here too without calling the neighbor list vector. This is a little bit convoluted, to be honest. But let's just do a separate function, because then I can remove these pieces and I can make them separate methods or separate functions if I want to later. Just follow me here for now. You'll see what I'm talking about later. So if I do a for each, and if I for each into my neighbor list, right? And I call this for each neighbor, this is where it becomes a little bit easier to look at. For each neighbor in neighbor list, for each of the neighbors I'm looking at, I want to start checking. I don't know which one it is, but I want to say that I want to look at the neighbor and I want to get the tile status for that particular neighbor. If it's not equal to the goal tile, right? If it's not the goal tile, because we want to check, then loop. Okay, why am I doing this? Because I want to follow the thing. It says, open the list is not empty. If it's not, then find the node with the least F, the least cost. That's what F is. And it says, for each successor, if the successor is the goal, stop the search. If the successor is not the goal, then do something. If it is the goal, then what I want to do, if it is the goal, so it is the goal, then I want to set the min tile pointer to whatever the current neighbor is. That's the minimum tile, because guess what? That's the goal tile, and that I don't care about anything else. That's the minimum. That's the one I want to choose, right? And then what I want to say, here's my path list. So my path list, I want to say, I want to push back that minimum tile to the path list, because the path list is just true, right? And I want to say that my goal found, this is how I'm going to end my loop. My goal found is true, right? Because I just found my goal. And I want to make sure I get the heck out of here and break. I want to break out of this, a hard break out of this for loop. So that's if the neighbor get tile status not equal to goal. Again, could I do it in here? Same thing? Absolutely. I can totally do it in here. I don't even need to have this neighbor list. I can just loop through each of the tiles in the neighbor list and not do a neighbor list at all. I don't have to do a for each. I'm breaking this out because maybe it might give me an opportunity to do different refactoring later. All right, now, what if it's not a goal tile? Well, that's easy. Let's start off with a simple algorithm. I'll say if my neighbor, right, and I'm going to get the tile cost. If I'm going to get the tile cost, if it's less than min, remember min starts off as like infinity. So if the tile cost is less than min, then what I want to do is I want to set it up so that min is equal to the neighbor get tile cost, right? So whatever the tile cost is, I want to set it to minimum, because minimum is going to be if its minimum is greater, okay? And then what I want to do is I'm going to say min tile, right, is equal to neighbor, right? So the minimum tile is equal to the neighbor that I'm pointing at. So whatever the neighbor tile is, which is a tile, remember I have 4 neighbor tiles, up, right, bottom, left. I'm going in a clockwise order here. Okay, so I'm looking at each tile and I'm saying, okay, for neighbor tile, I'm going to get the tile cost, set it to the min, and then my min tile is not equal to neighbor. And what I also want to do is the min tile index, I want to equals to count. So why am I doing this? Because I want to keep track of which is the minimum tile that I can remove later from the neighbor list. I want to remove it from the neighbor list, right? And I start off by counting at 0. So it starts at 0, and then I loop through, loop 3, and I'm going to increase the count plus plus. Okay, now again, could I have done it in here with my index at 0? Maybe. Then I would have to do a bunch of other shenanigans in here. All right. All right, so I'm looping through, and then what this does, this is the part that says if a node is set the minimum node, I want to set the minimum node, and if it's the minimum node, I want to basically get this min tile index, and I want to remove the tile from the open list, right, and set the new one, the one that I just found, that's the minimum one. I want to put that into the open list and go to the next one, and to the next one, and to the next one. All right, so I'm marching forward. So again, while loop, couple of for loops, and then after this thing, right? And again, I'm going to show you that there's optimizations next time. So if I go, now I want to remove a reference, or the reference, we'll say, from the of the current tile, which is the tile that's currently in the open list, right? Remove the reference of the current tile in the open list, right? We want to remove that reference. I'm going to say m underscore path list, and I want to push back p path list, and I want to push back, right, m underscore open list, and I want to push back the tile that's already there, because this is the tile that is supposed to be pushed to the path list, right? The original tile that's in there. Okay. So when I push this out, then I want to pop back m underscore p, pop back, or open list, pop back, which makes the list empty again. So empties the open list, right? Empties the open list. This removes it from the list and puts it onto the, the path list, the one that's currently in the open list, because the open list is going to hold all of the index to the paths. We're gonna make a list of vertices that go into the path, and that's what I'm getting. I'm getting it from the open list. Again, this could be optimized to make it different. This is just my thinking right now. Then I want to add the min tile, right, to the open list. This is assuming that there is a min tile, that we have a path. We're assuming some stuff here. Again, this is a first iteration of our code, and I'm going to say m open list, right, dot pushback. So I'm going to push back the min tile to the open list. So whatever the minimum tile that I found up here, I'm going to search through each of the tiles, each neighbor tile, and then I'm going to push back that one to the open list. I agree. It doesn't have to be a pointer, a vector at all. The open list is really just like a vector, one. But the thing is, it's either something that's in it or null. So you can say if it's pointing to null pointer, you can set it to null pointer, because all we're really doing with the open list is like literally only pointing at one thing at a time. Now, this is assuming, by the way, Nick, this is only assuming that we have one path that we're following. If I followed multiple paths at the same time, that's a different story. So, okay, so open list pushback, min tile, and then what I want to do is my neighbor list, I want to erase the neighbor list dot begin. I'm going to use the iterator, and the beginning of the list, I'm going to get rid of starting from the beginning of the list all the way to my min tile index, whatever that is. So that is going to be the tile index that I'm going to erase from the list. Why? Because I found the minimum tile from the neighbor and I want to get rid of it, so that I can take all the tiles in the neighbor list and add them to the closed list. Again, we could use the neighbor list as the closed list as an example. So here's the thing, something we can do to save this. Everything is closed. We add everything to the closed list. and then only remove the thing that's in the open list. We could have done it that way too. But I'm going to make another loop. All right. And I'm doing it so you can understand what I'm doing. Okay. So then I'm going to push all remaining neighbors, whatever's left over, right, onto the closed list. Okay. The closed list. So right now I'm not using the closed list, but I'm going to say for each, right, in the neighbor list, for each neighbor in the neighbor list, whatever's left over after I've removed the one that needs to be put on the open list, right, I'm going to neighbor list set tile status, right? So the neighbor, I'm saying, hey neighbor, let's set the tile status for this neighbor, whatever that's in there, to closed. But this is assuming that the thing I'm looking at isn't already closed or impassable, going with what Ethan was talking about earlier. We don't want to overwrite impassable tiles to make them closed. So we would check to see if they're not already impassable, right? And then we wouldn't add them in, okay? And then I'm going to say that m underscore closed list, right, dot pushback neighbor. And that kind of does everything that you could see. So let's go through it again. So again, from the top, and then we're almost done. Add start position to the open list, and then we push back that option, right? We set the open list to the starting tile. We make sure that the goal found is a Boolean that is a sentinel variable that can stop us when we find the goal tile, all right? We check to see if the list is not empty. If the list is empty, excuse me, or the goal is found, then what we're going to do is we're going to stop this while loop, okay? We set up some variables so that we can do some counting, right? As well as point to the minimum tile in the list. These are all temporary variables inside the scope of the while loop. So every time it loops back, it deletes all this stuff, right? And that's okay because from a scope perspective, even this tile pointer gets cleaned up, okay? Because it gets cleaned up as we go through the loop. It's in the small scope. And then what we do is we have a neighbor list. Could I make this, and this something that's smaller? Probably. I probably could, right? But for now, this is what I was thinking. And I'm just trying to follow this, right? So again, if successor is not in the goal, stop the search. If the node with the same position as successor is in the open list, then has lower cost than the successor, skip this successor. And if that's what I did when I did this whole min is equal to finding out the minimum cost. And then if a node with the same position as successor is in the closed list, which is a lower cost than the successor, skip this successor as well, right? So if the closed list is lower cost, go with that one, right? So we haven't done that part, and that's something that we could, because we want to look at the closed list again to make sure the closed list doesn't have a smaller component. Okay, so what about if I'm looking at a neighbor tile, right, as an example, I'm looking at a neighbor tile and I'm looping through and I want to put it on the closed list, but it's impassable. So if the neighbor is not impassable, right, then we can put it on this. Let's check that. We'll say if neighbor get tile status, and then we'll say if the tile status, right, if it's not equal to impassable, as long as it's not impassable, because that is something we don't want. And also, what about if it's or if it's the start tile? We want to put the start tile in the closed list either. So we're going to say or if it's not impassable, or if the neighbor gets tile status, one of those two options, neighbor get tile status, is not equal to start. We don't want that. Okay, so if it's not one of these two, then, and if it's already put on the closed list, that's another thing. So if it's not this, you know, if it's not start, and if it's not already in the closed list, because if it's on the closed list, we're putting it back on the closed list, and that can happen, right? You know, so these are things that can happen, and I'm just showing you a couple of instances where there could be a bit of a clash here. Okay, so how does this look now? Let's take a look and see what it looks like in the grid. So again, let's save it, and let's look at it. Again, is there an opportunity for algorithm improvement? Hell yeah, tons. All right, let's see I want to use Euclidean and click Start. And if everything went well, then I should see something here, right? Where if I click Start, then it's going to show something down here, right? Okay, nothing happened. This is bad. All right, that's good. So again, we're looking at trying to make sure we're good. Let's make something that displays the path list for us. So I'm going to make another little convenience function because we didn't see anything. We don't know why. Maybe it exited out early. So I'm going to say void m underscore display path list. I want to see the path list, right? Because it's important for us to print it out. We're almost done, guys. I'm sorry, I'm running right to the edge here. And let's generate implementation for this display path list, right? So again, I'm going to use a for each loop, and it's going to go to m underscore p path list, right? And I'm going to do auto and node for every node in the path list, whatever that is, node. There we go. For every node in the path list, I want to output standard cout where I have that open. This could have been put inside of some kind of overloaded toString method. Okay, so that's going to show each of the vertices, right? Threads, I know. And then finally, very inefficient code. But we want to make it work. Like I said, that's more important to me than efficiency in the beginning. Afterwards, we can hone. All right, so I want to show the path list size. So this path list, display path list, I want to do at the end. After I loop through everything, I want to display the path list at the end. Okay, that's inside of the find shortest path method. And again, we're going to try a couple things here to see how this all works, and we're going to go on from there. All right, let's save it and run it and see if we get anything that's printed out, but maybe not showing, because that's kind of an important piece. All right, it built. That's good. Here's my grid, and if I click Start, then how about Start? We kind of how about we wire up Start? Woo! Oh yeah, that would be good. We didn't wire up Start. Start is super easy to wire up. All we need to do in Start, again, we're going to go to our GUI function, and inside of where it says Start, we're just going to call find shortest path. All right, so in the Start button. Okay, and let's try it again. Just going to bring this over here so you guys can see in the middle of the screen. I want to show the grid. I'm going to leave it as Euclidean and click Start. And if everything doesn't mess up, and it looks like it did because it's going forever, then we would have this stopping. See how this keeps going, and it's building? That means I'm in an endless loop situation, right? All right, let's stop it, and let's see where we're going wrong. Now, troubleshooting time. So this worked. Go to definition. What did you say earlier, Nick? when did you need and for this here? Do you mean in the while loop, this part? Yes, probably and. Either one or the other. Yep, sorry, put the wrong thing in. And by the way, we can try and not put the open list in and see if that's the thing. But I'm pretty sure that this should be okay. And if not, we're going to try a couple more things. So again, here, I want to show the grid and start. And there we go. Boom. And you can see that it does a Manhattan distance. And here's the grid list on the left. So this is the path list, 1, 3, 2, 3, right? And it marches across 3, 3, 4, 3, all the way to, well, it gets to 8, 3, right? And then it starts going down like this and starts going down this way. And that's the shortest path. And that's based on Euclidean distance, okay? Now you're like, shouldn't it keep open? Well, no, because every time we go back, we've marked everything as closed. And that's because, my friends, that's because of the way we marked everything. That's our silly algorithm that's in here, right? So if the neighbor's tile status is not impassable and the tile is dark or this or that, it's got to be something that the way to look at this, actually, the better way to look at this is if it's unvisited. Exactly. So we just say if the tile status is unvisited, that's the only time we want to make that change. If it's equal to unvisited. Right, that's why we have that. If it's equal to unvisited, then do this, make it closed. Otherwise, don't touch it. Let's try that again. Otherwise, we're making something closed that shouldn't be closed. And we'll start, and we'll see that it goes like this. But see, we still mark these open tiles as closed. Still, the path length is 23. Okay, what about if it's Manhattan distance? So Manhattan distance gives us a different way of looking at it. What's the pattern there? So if I start, you can see that it is a definite different thing, and it's the same size, but the path is different. It goes across more and then down. So that's the difference between Manhattan distance and Euclidean distance. Euclidean distance gives us a different pattern. All right. Again, we're not moving. And the next piece would be, now that we have these vertices on the path list, we can make the ship move across, right? We can say that's the next step. We wouldn't do it today, but we can say, I want to move this to the next vert. So from 1, 3 to 2, 3, from 2, 3 to 3, 3, from 4, 3 to 5, 3 to 6, 3, all the way across and down to where it's supposed to be. We're not doing that right now, but this is the list that it would follow. And what we would do is we would just move the ship each step at a certain speed. Okay, and we can actually make a delay if you want to make it look like a board game where it goes from 1 to 2, 3, 4, 5 across this whole thing. So we're almost there, and there's still some optimizations to make. We also can show the path and what it's doing here. We have a lot of little things to still take care of. Sean says, all it says for me is path length 0. Well, that means there's something that stopped. It should count the size of your path. Let me put this up in GitHub before you guys freak out even more. So I'm going, because I know there's a lot there. So let's just go to GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say added find shortest path function. And this is like, first draft. We need a lot more drafts to make this better. We need to go through this and hone it. And this is what I'm hoping you guys will do before now and Sunday to make your path work better than this. You can play around and take a look at some of what I've written here. Well, how can you improve this to make it better, right? Home, sync, and push. Okay, for the lab, what I'm looking for is I want to see when you run it. So when I run this thing, I want to see at least 2 things. So I can switch between Manhattan and Euclidean. You should be able to do that, right? So if I go here and I switch between Manhattan and Euclidean, I should see an image like this for Manhattan and an image like this for Euclidean. Notice I had to, just turn it off and on. I'm GUI, and then it cleared everything. All right, a little bit of a bug. I'm so sorry. So that's Euclidean. And then when I do the start, there is no reset yet, but it'd be nice to have reset. But all that would do is reset everything back to its original things. If I want to move this around, I can still move this around. And a good test would be, what if I put them underneath each other and I click start? Then it should be very short, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. You can see that it's working, right? So it goes all the way down from here to there. And I'm using Euclidean distance, right? And you can see that because the decimal points are what they are. Or the other thing you can try and do is use Manhattan distance. So again, I would turn this on, click Manhattan, move this around, let's say. So let's move this here and somewhere else, another little area. Put the grid on and then click start. And then it's a path length of 14. And then you can take this away and you can see that this is clearly a path length of 14. One thing that's not showing is the open. You should be all the open would be here, but we've marked them all as closed. And that's because of my little weird thing. When I loop through everything, I'm marking everything as closed as I'm putting it back on. And there's got to be a way that something that I missed, that I should have not marked it as closed when it's already in the open list. Okay, I didn't check that. I'm so sorry. But notice the path length has changed. One thing I can't do right now is I can't press start again, right? I don't have the ability to do that. Why? Because I've already calculated this path. I've already filled this up, right? And I have no way of doing it again. I haven't got to there yet, all right? And I just ran out of time. It's 6:06, and I think we've done enough for today, all right? So again, if I want something like that and click start, it's not going to run because I've already got the path and it's already found the goal. I have to reset that. When I click it, then the goal has to start off at 0 again. I can't do that, right? Because it's going to stop if the list is empty or if the goal is not happening, right? And you can see clearly that I'm in an endless loop right now. So that is something that I would fix in another iteration. Okay, questions around this. This is kind of your beginning, your first draft, if you will, of your find shortest path algorithm. What would be nice to leave you with this thought as well is, what would be nice if we made something called a path manager, that you could use something like that. This find shortest path would be part of a class, a singleton, which would be your path manager, and that you could take from one scene to the next scene. Here we're locked into this this play scene, and it doesn't exist anywhere else. I want to be able to port this right to another scene, and I have to have another class to do that. Okay, again, lots of crazy stuff that I can go through here and hone and take this away, and we can try to massage some of the little for loops that I have in here so we can reduce this and to make this much more efficient and less computationally expensive. All right, any questions before we go for the day? I'm sure there's tons. I'm going to stop recording and I'll take some questions here. So for the people that are watching on YouTube, then thank you so much for watching. I appreciate you coming out. Meanwhile, I'm going to take some questions from the people that are in the class, and I'll see you guys next week. Remember, next week, before you go, we have a test that I will release Monday, Tuesday timeframe, and it'll be due by the following Sunday. All right, so make sure you take a look at your PowerPoints and so that you study up, because your time is going to be your enemy on the test, not the difficulty. The difficulty is low, but the time, you're going to have to look through the information you have, and that's going to slow you down a little bit. Okay, so thank you so much for this. I'm going to stop recording now, and I'll see you guys next week. Thanks so much, Kai. All right, any questions? So Sinan, can you explain